Okay, so we've got a non-uniform rod here, okay? And it's important to note, when you've got a non-uniform rod, the centre of mass will not go through the centre, okay? It will go through somewhere else. So you can see I've got the reactions here at C and the reaction here at D, right? And they've got the distances. The reaction at C is 1.5 metres from A, okay? But the reaction from D is 5 metres from A. And this rod, of course, is 8 metres in total, all right? So I've got the weight going about there. That's where I reckon it might be, because if you notice here, here's the centre of your rod, and the reaction at D is quite close to the centre. Okay, so I reckon it might be here, but I might be wrong. It doesn't matter really where I've drawn it. But that distance then is x from C. That's what they want. I called it x, right? From C there, because they want the distance of the centre of gravity of the rod C, of the rod from C. So the centre of gravity will be here, and the distance then to C I've called x. So if I take moments about C, okay, so if I take moments about C, it doesn't matter about the reaction then, so I've got then, that's sort of like the centre of my clock, so then 7.5 g is going clockwise times that distance x, and that will equal then the anti-clockwise, and this is going anti-clockwise of course, which is 56.7 times the distance there. Now you've got to remember it's 5 metres to 56.7 to D rather from A, but to go to C to D, of course I need to cut 1.5 metres away, so it'll be 3.5 metres. It's actually 3.5 metres distance between those two. Okay, so 56.7 times 3.5 will be 198.45, and 7.5 times 9.8 then here, okay, right, so I get x then to equal 198.45, so if I divide by that 73.5, I get my distance then of x, so it's 198.45, divide by the answer, I get 2.7 okay, meters. That's what we're going to have there, okay, so 2.7 meters is what x is going to be, okay. And then it says determine the reaction of the support at C on the rod. Well, because it's in equilibrium, I can say, look, forces up equals forces down. Now I'm told the other reactions, that's good. So I've got RC plus then the 56.7. That will equal the force down, which is 7.5 times 9.8, which is 73.5, wasn't it? Newtons. So then quite simply, then RC will be 73.5, take away 56.7, so I get 16.8 newtons.